Good evening. My name is Lukas Hatala, and I come to say something about Internet of Things. We will start with the presentation of the IoT technology in this short introduction, which is called IoT in the nutshell. In our agenda, we will be focused on the evolution of the technology itself. We will talk a little bit about the definition of Internet of Things. Then we will mention research, development and implementation challenges, some existing standards, service-oriented architecture, service-oriented device architecture, and as well as reference architecture and some visualization, how this architecture is interacting with the real world. And also about an technology which is maybe a solution for the most painful topic, what we are challenging at the moment. And as well some recent activities which are ongoing in our enterprise world. So evolution of Internet of Things started around 300 years ago by the first wave of industrial revolution, which were powered by the steam power, followed by the second wave of industrial revolution, which came with Nikola Tesla and electricity into our plants, as well as followed by the Internet age and age of information, which were started in the year 1948 by Claude Shannon by definition of theory of information entropy. And in year 2011, Dr. Honbo Zhou defined and smart objects and middleware perspective for Internet of Things, what is practically the base block of this technology. And from this time, we can consider IoT not for a buzzword, but for the technology itself. So, what's the IoT? Let's say that IoT is pretty everything. That's a dynamic global network infrastructure with self-configuring capabilities based on the standard and interoperable communication protocol, where the physical and virtual things have identities, physical attribute, virtual personalities, use intelligent interfaces, and are seamlessly integrated together into the information network. So that's a group of physical entities which are represented into together information network in term of virtual entities and describing their relationship to each other. So from this point of view, we can say that Internet of Things is close to everything, as we will show later on reference architecture slides. At the moment, IoT is definitely not a mature technology. That's really a new technology. And research challenges are ongoing. The biggest challenge is integration of the informations from network from very heterogeneous sources, like machines to machines, SCADA, radio frequency identification, wireless sensory networks, which have quite own sets of protocols, standardizations, encodings, as well as time series and stuff like this. As well as we are requesting, due to unpredictable amount of data and scalable background system, which have to be able to load from 10 requests a second to billions inputs a second. So we are looking forward to build this infrastructure into the cloud, which is leading to the next research challenges, how these virtual metadata layers will interact together, as well as data filtering and notification. Imagine that we would like to force really small devices with application with footprint around 20 kilobytes to talk to the business processes into the ERP system. And this is really something not easy, because there can be around 1,000 of receivers of this data. And if such small system, which is harvesting the energy from the surrounding, have to keep in mind 1,000 objects which are interested of its data, it seems to be quite problematic, because there is no place where it can be stored in such small object. So the data filtering and alert notification seems to be a really challenging task in order to fulfill all the requests which are coming to the IoT system. Development and deployment of the services. That's, let's say, more architectural problem than the technical problem. And big companies like IBM, Hewlett-Packard, Siemens are trying to create together APIs in Industrial Interconnect Consortium in order to be built an industrial internet, like extension of our internet. Cisco defined a concept of fog computing. They would like to build a lot of microclouds around us. Microcloud or fog computing should be something like this, that you are walking on the street, you have your device in your hand, and you are just looking on the fog of services around you. So services have to be everywhere, and the system which are composing IoT shall to be autonomous systems. So that's the idea on the background. Development and implementation challenges. The biggest one is the availability of the internet connection. At the moment, it is quite easy if all your devices are able to talk to a gateway, which is able to provide you connection to the internet. But what if you are trying to sensing on the bigger geographical area, and you have to use more hops and then internet? How allow IPv6 packet to go through these hops, as it is routed technology, and each sensor, each sensing point have to act as well as a repeater and route these packages in the mesh networks by the correct ways. Security and the privacy. That's really a big issue, and a lot of problems are already caused at the moment. A lot of people are complaining. If you will install a camera on the train station and you are seeing the faces of the peoples, if they are looking on your commercial, who is the owner of the data? Is owner of the device also owner of the data? Or person on the camera is owner of the data? What about privacy? What about security? What about monitoring of the habits of the people? So it comes also with huge amount of legal changes in European Union, which are actively reconsidered by European Research Cluster and periodically evaluated. So not so simple to implement IoT system. Power consumption. As amount of transistor on chip is every year doubling according to Moore's law, as well as power consumption is dropping by 70% from year to year. It is still more and more realistic to build an sensing equipment which is able to harvest energy from the surrounding, or build the system like this one what was deployed now in Italy, the parking system, where you have to change the battery every 5 years, for example. But still, this is something would have to be assumed. How you will get enough of energy to your Internet of Things system? Because keep in mind that your system is distributed on very high geographical area, and not every sensor have possibility to be connected to the electricity grid, because electricity is not everywhere. Also, the sunlight is not everywhere. Fault tolerance for home automation, smart city, parking system. One missing packet means close to nothing. But for e-health system, for something what is really monitoring and security in an production line, there is not acceptable to miss any single one packet, because you can cause a serious injury to somebody, or somebody can die. So data loss and fault tolerance is a big problem at the moment, and we are trying via various quality of service somehow improve that and be sure that we will not lose any single value. Standardization. The nightmare at the moment what we are facing is that every company, IBM, HP, Cisco, doesn't matter who is it, Siemens, everybody would like to have a proprietary standard for Internet of Things. Everybody would like to sell a standard. There are already approaches like Open or Interconnect Consortium, Industrial Internet Consortium, and some others as well, which are trying to harmonize this effort and find together standards, together protocols, together encodings. But it is not so straightforward as they are presenting from the outside world. As well as acceptability among the society. Imagine that you can build the system, but if nobody will trust the data from the system, or somebody will not feel secure to publish the own data by participatory sensing there, they will be simple there in low quality, incomplete, or will be not consumed at all. And why to build such technology? Standards. Standards is an easier path, let's say. Actually, by using standards, we would like to interconnect already existing networks. And from this point of view, IoT consists of radio frequency identification systems, wireless sensor networks, SCADA systems, and machines-to-machine system. All of them together are doing Internet of Things. Radio frequency system have an own standard like near field communication, EPC global numbering, -7 open protocol. Wireless sensoric networks are one of the top contributors at this area with 6 LoWPAN protocol and with RPL. RPL is very important if you would like to come with packet from one point to another through the mesh network without possibility to deploy the gateways frequently. SCADA systems, BACnet, and all protocols included under this specification. OPC Unified Architecture, Profinex, KNX, EIB. All of them are very difficult to integrate also in a building automation system or in the industrial control system. And what about integrate building automation system, industrial control system, as well as VSN system, also RFID system, ERP system, and then ZigBee machine-to-machine system, and all of them together into one business process. So, without common protocols and encodings and standards, it seems to be really, really challenging task. Okay. How we would like to achieve such a task? What we have at the moment? At the moment, we have plenty of devices. we have sensors, actuators, PLCs, HMIs, and various systems in the building automation system which are already deployed. We already have an IT systems which usually are built in the service-oriented architecture fashion. There is usually an enterprise service bus with a broker which is taking care about registered services and accepting services to the bus. But all what is between the devices at the bottom and the ESB at the top is area of our interest. We have to build and protocol adapters and device interfaces which will interact with the physical entities on the hardware level, on the protocol level. Then we have to create the agents, device and scenario specific logic. We have to transform the physical entities into the virtual entities, which can be later used for exposing the services to the enterprise service bus. Then we can apply our application logic, our application code, which can translate the virtual entity together with sensing value to do something what can translate our service directly to our enterprise service bus when it can be consumed by the fashion why we are doing it very frequently, like this guy on this smartphone. That's quite normal. You will register for a service on a bus, you will choose which one, and you will simply consume that. Or consume two services and create one application of that. Such integration logic, which is stacked of several layers, is usually powered by a development tool. I used for my experiments OSGI from Eclipse, and it must be supported from the left side by an adapter services, device services, which help you with this translation, because there is not possible to accept such stacked approach for every single one sensor or actuator. You need to have universal layered box which will able to accept various sources of the data, and through the services coming from the left side we'll be able to choose the correct execution logic in order to produce the service at the top, which can be integrated to the existing infrastructure. This approach is SOA approach. SOA approach and enterprise application integration is something what is very well known nowadays. But the approach with service-oriented device architecture and machine application integration is something really new, which is creating new level of complexity to our existing IT system, and we have to somehow react on that. Actually, a lot of efforts are ongoing, somehow standardize it, and we will mention some of them later. Okay, this is nice to present a stacked layer, how to achieve some integration, but what about reference architecture? How we can build something with architecture? This is pretty close to impossible if you have to repeat that, if you have to maintain that. That's why Siemens, SAP, IBM, Fraunhofer, and many others sit together, spent 5 million euros, and produced reference architecture. Reference architecture is again the same as the stacked approach. The devices at the bottom and the applications at the top are excluded from the reference architecture because they are already existent and they are not IoT systems. They are only the systems between what we have to include this reference architecture in order to interconnect them. So we need a communication layer which will translate our encoding and protocols into something what can be consumed by IoT service. IoT service can be exposed on API directly to the application, as you can see. From this service, we are creating the virtual entities. Virtual entities can be one-to-one relationship with physical entities or one-to-many relationship in terms of physical entities. So we are free to choose or design the virtual entities in order to present the complexity like we want. That's a big thing. We have also possibility to process management. This is not about that IoT system is autonomous or self-maintainable. We are able, from our application, from our ERP system, we are business to manufacturing markup languages, send the messages directly to the service organization and IoT process management frameworks, the commands which can help us to send it through down to the actuator levels and change the state of the real world in order to be better coordinated with our business process world. We have also two dark blue boxes at the screen at the moment: the security and the management. Security and the management are not parts of the IoT system, as they are not functional part, but they are very, very important. Without security, you are not able to guarantee authentication, authorization, certificate distribution, encryption, and stuff like this. And without management, you are not able to start business process engine, business process execution language modules and stuff like this. So they are very important, but they are not functional part. That's why they are in different color. Maybe it will be more clear from this picture, which is more illustrative. We have the devices at the bottom. We have the IoT applications at the top, which are representing our smart city, smart transport, building, energy, industry, health, living, whatever. Doesn't matter what is the application. The referent architecture is the same. Doesn't matter what's the use scenario there. We have to, at our network and communication level, provide a gateway, quality, addressing, and routing, as well as network and transport capabilities. That's practically a transport level. It will take the data from the device level and drop it to the higher level. Higher level is service level. Service level is able to interact directly with the applications at the top. You can use API there. But what is interesting is this virtual entity level, as there are discovery and the resolution services running. That's the point where the industrial internet is formed, where the universal resource identifier can be issued, where you can just pick up the points which you are interested in for your reports by drag and drop in your self-service BI tool. And as well as that's the point from where are these modeled virtual entity, which consists of, each one consists of one or more physical entity and some math inside, just to get a necessary output value in necessary aggregation level. These virtual entities are directly affecting our business process modeling engines. So that's the point, this small box, where our ERP and IT systems are interacting with the real world. At the left side, we have an orchestration. That's quite same as with cloud. If you would like to achieve something, we need an orchestrator which have knowledge about the core of the system. We have to send him a command and trust him that he will model the virtual entity and the touch points to them, as we will need it in our business processes. Security, authorization, keys, trust, identity authentication, and the management capability, QoS, that we will not lose the packages, and the device manager, which is aware of the integration point provided by reference architecture. So my question is, why we are inventing wheel again? We started with the specification like ISA 88, ISA 95 around the 80s of the previous century. We achieved quite good results. I don't know if somebody aware of OPC unified architecture. 1, 2, 3, 4, 5. Oh, not so bad. OPC is something what was really a crap few years ago, because it was running on its DA, HDA, EI specification, which was quite cool, but was relying on DCOM technology. And the DCOM technology was quite nightmare from an authentication and security point of view, and usually integrators granted all permissions, and there were no security at all in a planned production system. But few years ago, around the year 2006 to 2008, few guys from ABB decided that they will make an OPC specification, vendor and device independent, and evolve it into OPC unified architecture. OPC unified architecture can scale from the all levels of automation pyramid, from the sensors and actuators to the PLC level, to the manufacturing execution system level, directly to the ERP level. All the system can deploy OPC unified architecture or OPC unified architecture adapter. And as well as it supports ISA 88 specification, what is practically Wallman decomposition for the industrial process, and ISA 95 specification, what is business to manufacturing markup language, as well as collaboration with building automation, MESA International, MESDAC, as well as RFID, Auto ID, Oil Gas, and MT Connect. And this new ID working group, what 3 weeks ago established Siemens and this, I think the Fraunhofer, which are now creating new ID infrastructure for Internet of Things. OPC unified architecture is going to be transport technology there. So I'm asking, as we covered machines to machines, SCADA system, radio frequency identification, and partially wireless sensoring networks, why we are developing the next protocols, as interoperability standard is already deployed previously. We have to talk on every device in human-machine interfaces, in our case, by plenty of languages in order to be able to talk to the whole underlying process. But now we are talking by OPC, and OPC will translate our commands to the underlying device. And in fact, we'll create a virtual metadata layer and will hide the underlying complexity. It's produced like EEC standard, so I really don't understand sometimes the purpose of some activities of big companies. These activities are at the moment at the top is Industrial Internet Consortium, where we are discussing the things like IPv6 acceptance, if it is good to extend actual internet, or it is better to go through the 5G networks directly, because in the internet are a lot of devices which are not able to work with IPv6 packets at the moment connected. And as well Industrial Internet Consortium, where we are trying to discuss about what protocol to use, if we will create a new protocol, if we will create universal gateways or integration device, or how we will solve the interoperability issue. IoTA project, which is already finished, which somehow successfully defined the reference architecture model and some other methodologies how to achieve Internet of Things system. In European Research Cluster and Strategic Research Innovation Agency, which is European Union funded project, which is keeping an eye on legal changes, technological changes, and coordinating activities of big companies and universities at the research area, and also producing papers based on that. And I consider for very, very, very important to mention also OPC Foundation. Also due to the fact that OPC was chosen by Microsoft Azure Cloud to make an OPC interface for IoT system integration in the Microsoft IoT solution. I think that it was announced 2 or 3 months ago. Okay, so where we are. High-level architecture is clear. Transport infrastructure and interoperability solution is actually at the development or discussion. And the protocols as well. So let's say that we know where we are going, but we don't know how we will get there. So do somebody have any questions?
Because what happens if this OPC will become such a nightmare as Java?
It is already a reality. OPC is delivered in the FAI code stacks, and one of them is Java stack. .NET, Java, and ANSI C code stack. What?
What about Scala? What about Scala programming language?
I'm not aware that an EIC specification code stack is released in this language. I don't know anyone, so I don't know, really. Any other questions?
So I would like to ask if there is any, or if there are any thoughts of using UPnP as some guidelines for making such a protocol that could work already.
That's definitely the language which do not have the modeling capabilities and don't have a rich data model. That's why it is something what is going to be integrated but something else like OPC later on. And as well, by introduction of HTML5, we expect that RESTful applications will fully replace such technologies. Any other questions? Maybe also when Y1 or... Okay, then. Okay, thank you for your attention.